This is problem 16.5 Neetcode 150 combination sum. So in this problem, we're given an array of distinct integer, no duplicates, and we're also given a targets. And our task is going to be to return a list of all the unique combinations inside the num input that can sum up to that target. But we can return basically every single numbers in an unlimited frequency, meaning that if, for example, our target is 10, we can absolutely return 5 times the 2. So this is where it gets a little bit tricky. And for the example 1, we can see that the solutions are 2, 2, and 5, which makes sense. Or you can have also just 9 because the target is actually a value in the array. So at first glance, it might seem a little bit tricky. We can see here on example 2 that to get 16, we can add 4 times 3 plus 1 times 2, or 2 times 3 plus 2 times 5, or 4 times 4, or 1 times 3 and 2 times 4 and 1 times 5. So this makes the problem quite more challenging, but let's see how we can solve this problem. We are going to use backtracking to solve this problem. So let's say we start with 1, 2, and 4, or 1, 2, 3, okay? And we want to go to 8. So this 8 is our target. Let's just say T. Right, so the target is 8, and we have 1, 2, and 3. So first, we want to take our 1, just like this, and we want to call a recursive function on it so that we can keep adding 1. So here we'll have 1 and 1. And we can also have then 1 and 2, right? So on each recursive call, we basically have to provide the option where you can add the exact same value in it, or you can add the value at the next index, okay? And one thing that we also want is to avoid duplicates in our answers. For example, to find the solution, we can have 3, 3, and 2, right? So this is a solution, but we want to avoid having, let's say 2, 3, 3, or 3, 2, 3. So if we have this, for example, well, this will be incorrect because they are considered duplicates, so we cannot provide this as an answer. So with that being said, the logic here is that for the number 1, we are going to iterate through all its possibilities, adding the next number, adding itself, and on and on. But once we actually start a new call where the first value in the array or of the solution is 2, we are never going to look at adding 1 again, because when we added 1, we went through all the possibilities that included a 1. So now we want to have all the possibilities with a 2 that doesn't include a 1. So we're going to go for 2 and 2. And we're going to go for 2 and 3. All right. And now at at 2 and 2, we are going to have 2 branch. So we are going to have 2, 2, 2, which is going to be 6. Excuse me for the in the writing. And we are going to have 2, 2, and 3. Excuse me, it doesn't look like a 2, but all right. And now for the 2 and the 3, that we had here, well, since we added 3, the same logic is going to apply here, right? Since whenever we add a value that is at an index of value greater than the index of the previous value add, right? So when you move to the right in the array, so we added the 3, we are never going to add back another value that was before that. So in any example, if we add a 1, it's it's um it's possible that we add another 1. It's possible that with our array of 1 we add another 1, so we have 1 1 1. And this is not only possible, this is what we want, because 8 times a 1 will be one of the solutions. But for the moment that we add a 2 in it, we are never gonna add a 1 again. Okay, so this is quite important. And the moment we add a 3, we're never gonna add a 1 and a 2 again. So with that being said, I think we can jump into the code. We are gonna do a recursive call for that. So the first thing we want to add is an output array where we are going to add the solutions once they exist. And now I'm going to create my depth first search function. And what do we want to pass inside this depth first search function? Well, we want to pass an index. So this way we can go through every single numbers in the array of nums that we're given. And knowing this will help us also handle the logic where you won't add a number that has already been seen in the array. So I is not the only value that we want to add inside our depth first search function. We want to also have a state of the current values that we have in our let's say current. For example, if we start with 1, well, the current in the next call might be 1 1, and then the current in the next call after 1 1 might be 1 1 1. So we want to make sure that we keep track of this current. So let's call this cure. And also we want to have a way to measure the total value that all these values adds up to, because we know that if they are equal to the target, we have to add this cure combination inside the output. So we are going to have a total. All right, so now within our function, the very first check we want to do is we want to check the total, and we want to see if the total is equal to the target. So if total equals target, well, this is where we want to append to the output the current combination. So we are going to say output that append, and you want to add current, but we don't necessarily want to add every single current of every recursive calls. We are basically going to say copy, because we want to have a copy of the one that we are at, not only all the recursive calls. So this is how we are going to do. Otherwise, we are going to receive a pretty messed up results. The second call that we want to check is basically, did we actually went through every single values? So the way to check if we went through every single values is to check if so if the index is equal to the length of the nums, right? Because every time we are going to end a recursive calls, or for every recursive calls, you're going to create 2 branches. The first one is going to be where we add the number itself to the same cure, and the second branch is going to be where we add the next number in the array. But it is possible that at some point we arrive at a place or an index that is out of bound, and this index is going to be basically when the I is equal to the length of the nums, right? So this is the first check we want to do. Or what if the total value of all the numbers inside our cure is actually greater than the target? This is where we know that we actually messed up. So we're going to say that if we are out of bound, or the total is greater than the target, well, we are just going to return our recursive call without doing anything else. All right, now this is where we want to have our two branch. So let's just define them. So first, depth first search call, second depth first search call. But actually, how do we manage them? All right, how do we manage the first call where we are gonna add the exact same number inside its array? We are gonna say output. Um, no, pardon me. We're gonna say current that append. So we are gonna add to the array the nums at the index I, and we call that we never incremented the index I so far. We're just using the one that we're passing to the params, meaning that that we are gonna receive the same index of the previous value in this call, right? So in this call, we want to recall the same index. We are gonna pass the same current. Well, the same current is the one that we had and that we appended the exact same value to it. And we want to also make sure that we adjust the total. So it's going to be total plus the value of the nums at the index I. All right, so this is the first call. So you see that if we have one in our array, if we take back this example where we have 1, 2, and 3, initially, or 1 is going to hit this target. So we are going to append 1 to here, and we are going to call back I, and I is 0, right? Because the index of 1 is actually 0. The current is going to be equal to 1 at first, and the total is going to be equal to to 1 because we just added. And after this, we are going to go back in depth first search in our depth first search function. And if we hit this again, right, we are going to append 1 again to it, and we are going to call another depth first search function with that same index I. So this is how we are going to add the same number again and again and again until we either reach the target or we have a total value that is greater than the target. Okay. The next function though is what do we do if we want to add the 2, right? So now we added all the ones. Now we want to add a 2 to it. So we are going to first pop out a value. So we're going to say here the pop, and the reason is when we first add a 1 to the array, we then pop the values, and after this we are going to call another recursive call on the next index. So 1 plus I plus 1. So this makes that we are going to reach the 2, and we are going to start a new array that starts with 2. And notice that when we call this recursive function, we are going to call it with the index that is greater than index 0. So after this, we are never, ever again going to call the value 1, right? So remember when we said that we never, like whenever we add a value that is greater than that is to the right of another value. So if we pass from 1 to 2, well, we are never going to use 1 again. And if we pass from 2 to 3, we're never going to use 2 or 1 again. So this is where we are going to do that. Once we pop the value, we're going to say 1 plus I plus 1, and we are going to pass the current. And the current is basically, for the first round, is going to be empty. And the total is still unchanged because we didn't add anything. So this is what we want to set. So after this, we are good to call our function, and we want to make sure that we start at the index 0, and that we set the cure to an empty array, and that we set the total to 0 at first. After this, we can return the output. Okay, so if we go, just do this example here, 1, 2, and 3, we're first using the index 0. So at the index 0, we are first going to append through the current 1, and we are going to send another recursive calls with the index 0 again, with the current that is an array containing 1, and with a total that is equal to 0 plus the value of the nums at the index 0, which is 1, meaning that this total is going to be 1. And after this, we are popping the values, and we are adding the element, and we're calling the depth first search function at the next element. So we are in our second recursive call going to reach the we're going to reach this here that append nums I, but the nums I is actually I is num, so we are going to add 2 to this, and then we are going to recall this depth first search function with the same index I, which is 1, and our cure that is going to be an array containing 2, and our total that is going to be basically 0 plus 2, so it's going to be 2. And after this, we are going to pop this value again of the 2, so we're going to have an empty array again, and we are going to call another depth first search function with the index I plus 1, so we're going to be at index 2. So we are going to go again in depth first search function, and when we reach this, we are going to add we're going to append to here the value of the nums array at the index 2, which is going to be the value 3. And we're going to recall our function with the index 2 again, with the current that is containing 3, and the total that is basically going to be 0 plus 3. So I hope you can hear the music in this algorithm and see how beautiful it is and how it works quite well. And now we will run the algo and see if we didn't do any error. We did an error. Let's try to figure this out together. So we are creating our output array. We are defining the first search function with I, with the current and the total, and we are saying that if the total is equal to the target, we are gonna add a copy to the output of this current, which is good. And then there you go. Do you have to return? Okay, so this is quite crucial. I don't know why I missed that, and there you go. So I hope you learned from this video, and I hope to see you in the next one.